Basic identities. An identity is an equation that is true for any value. For example, from algebra, we know that x plus x equals 2x. It's simply a fact. If you take one x plus another x, you get two x's. Doesn't matter what the x is. You can stick in 10, which would be 10 plus 10 equals 20. You can stick in 100. 100 plus 100 equals 200. It doesn't matter what value you substitute. That equation that I just wrote down is always true. Well, in trig, there are zillions of identities. There are just lots and lots because there are so many relationships between the different trig functions. The ones that we're going to introduce right now are so foundational that they really need to be committed to memory. The first group are called the reciprocal identities, and these are very simple. Let's take a look at one. Cosecant theta equals 1 over sine theta. This is a fact we've been using for a long time. 1 over in math is simply a way of expressing reciprocation, and we know that the sine function and the cosecant function are reciprocals. We're just writing that down now. Of course, that means the same thing is true for the secant and cotangent functions. And so we have secant theta equals 1 over cosine theta and cotangent theta equals 1 over tangent theta. But of course, if these three are true, the reverse relationships are also true. Reciprocation works both ways. So we have sine theta is 1 over cosecant theta. Cosine is 1 over secant. Tangent is 1 over cotangent. These reciprocal relationships are crucial in trig. How can we use these identities? Well, let's take a look at an example. If cotangent theta is 3/7, find tangent theta. Well, I just need to determine which of my identities applies here. I want the one that gives me tangent theta when I know cotangent theta. So that would be this identity here. Tangent theta equals something involving cotangent theta. So I could write tangent theta is 1 over, and then in place of cotangent theta, I'll write 3/7. 1 over 3/7, that's the same thing as saying 1 divided by 3/7. I'll write 1 as 1 over 1. I'll change to multiplication by flipping over the second fraction, and I end up here with 7/3. So tangent theta is 7/3. I used that identity to come up with the answer. Now I will say, in practice, for an example this simple, most people simply remember the reciprocal relationships. If cotangent theta is 3/7, all I have to do to get tangent theta is simply flip that fraction upside down. So I can immediately write down, of course, tangent theta is 7/3. The next set of critical identities are called the quotient identities. Let's take a look at the first one. We have tangent theta equals sine theta over cosine theta. This is very easy to prove using our unit circle definitions. You can recall that the sine ratio sends you out the b coordinate, and the cosine ratio sends you out the a coordinate. Well, tangent gives you b divided by a. b is sine theta, a is cosine theta. There's the quotient identity. Tangent theta equals sine theta over cosine theta. This is great because we now have an equation that links up all three of those ratios. There's one other quotient identity. We have cotangent theta is cosine theta over sine theta. I think there's two ways you can convince yourself that's true. One way, of course, is that we know tangent and cotangent are reciprocals. So, of course, if you simply reciprocate this fraction, you get this new fraction. Or you can look in the unit circle definitions. The cotangent ratio is a over b. A is cosine, b is sine. Be sure to memorize these identities. They are very, very important. Let's look at an example. If tangent theta is 1/5 and sine theta is negative root 26 over 26, we want to find cosine theta. So I know tangent, I know sine, I want to find cosine. Obviously, this is the identity that should come to mind. Now, I want to know what cosine theta is. So before I do anything with the numbers, I think I should manipulate this identity around a little bit so that cosine theta is what's on the left and everything else is on the right. In other words, I want to solve for cosine theta. I will multiply both sides by cosine theta, giving me cosine theta tangent theta equals sine theta. And then I will divide both sides by tangent theta. And that gives me a version of the quotient identity that I can use in this problem. Cosine theta is equal to sine theta over tangent theta, simply a different version of that quotient identity. Well, I'm all set now. To use it, I can simply plug in the values. I know that sine theta is negative root 26 over 26, and tangent theta is 1/5. All I have to do is simplify here, and I'm all set. Well, once again, I know that that giant fraction bar just means divide. Dividing by 1/5 is the same as multiplying by 5 over 1. So as soon as I do that, I have my answer. And I get negative 5 root 26 over 26. That's the value of cosine theta. By the way, you should be able to tell what quadrant our angle theta must be in. The tangent ratio was positive. The sine ratio was negative. The cosine ratio was negative. Well, where are you where sine and cosine are both negative and tangent is positive? All students take calculus. It's quadrant 3 where only the tangent function of the big 3 is positive. Okay, now we get to the granddaddy of them all, the Pythagorean identity, maybe the most famous trig identity and one that we will use over and over and over again. I can derive it for you using the unit circle. We know for any angle we draw on the unit circle, I'll call the angle theta, we will end up intersecting the unit circle at some particular point, which we have been calling A and B, A comma B. Well, I can represent those coordinates by dropping this perpendicular. This length here would be A, this would be B, and of course, since this is the unit circle, the radius is 1, and so the hypotenuse is 1. Well, I have a right triangle here, which means I can apply the Pythagorean theorem. A squared plus B squared must equal 1 squared. Well, based on our definitions, though, we know that A is just the cosine ratio. So I can replace A here with cosine theta. And we know that B is the sine ratio. So I can replace B with sine theta. 1 squared, of course, is 1. What I have just written down is called the Pythagorean identity. We usually write it a little bit differently, though. So that we can avoid the parentheses, we'll write sine squared theta. Now, sine squared theta just means this. It means take the sine ratio and square it. It doesn't mean square theta, the angle. It means square the ratio, the length, the coordinate. Typically, the sine squared theta is written first, followed by cosine squared theta. Again, that's simply this, equals 1. This is called the Pythagorean identity. Definitely commit it to memory. It's a wonderful identity because it links up the sine function and the cosine function. Let's take a look at an example. I have the sine ratio. It is negative 2/3. I'm also told some quadrant information. We'll see why that's important later. And I want to find the cosine ratio. Well, the Pythagorean identity is perfect for this situation because it links up the sine ratio and the cosine ratio. Let's see, I need to plug in the sine ratio and determine the cosine ratio. Be very, very careful. You might want to, while you're learning this, write out the Pythagorean identity with the parentheses. This is what sine squared theta and cosine squared theta actually mean, and you might find that helpful as you're doing your work. When I fill in sine theta, I'll fill negative 2/3 in that parentheses. I'm not filling in something for theta. I have no idea what theta is. I know it's in quadrant 3. All I know is the sine ratio. That's what's being squared. Now I can solve this equation for cosine theta, which is what I want to know. Let's see, negative 2/3 times negative 2/3 would be 4/9. And then I need to subtract 4/9 from each side. Let's see, how do I do 1 minus 4/9? Maybe I better go off on the side. 1 would be 1 over 1, common denominator of 9. So that gives me 9/9 minus 4/9, which would of course be 5/9. So now I have cosine theta all squared. That ratio being squared equals 5/9. How do I undo a square in algebra? I do that by taking a square root. Hopefully you remember, though, from algebra that when you square root both sides of an equation, there are two possible solutions, a plus and a minus. When you square root both sides, you must include the plus or minus. Now, in our situation, we're not going to end up with two answers. We're going to have to choose here. We're going to have to decide which of these answers is the right answer. This is why this quadrant information is given. Without that information, I really wouldn't know how to choose. Let's see, I'm in quadrant 3. In quadrant 3, all students take calculus. Only tangent is positive in quadrant 3. Therefore, cosine theta must be less than 0. It must be a negative value. So I'm going to choose the negative. I would suggest always write down the plus or minus and then circle your choice. All that's left here is to simplify. I know the answer is negative. I can split the square root into two pieces. And then the square root of 9, of course, has a nice answer. And so what I have determined is that cosine theta is equal to negative square root of 5 over 3. Make sure you practice this a lot. Thanks for watching.